So hello everyone, welcome to our lecture 7.4. So ang lecture 7 natin is about fluid and now we are talking about the Bernoulli's principle. So in this part, pag-aaralan naman natin ang fluid kinematics and fluid dynamics in opposed sa fluid statics doon sa part ng buoyancy. So now, pag-aaralan muna natin what is a fluid flow. When we say fluid flow, it is the flow of fluid. Technically, if you have a path here, isa siyang mahabang tube, then you have a point, 2 points here, A and B. A and B. Ano siya? This other end is also circular. Ang fluid flow will be moving from one point to another. Kita ba? Siya daw ito madilim. It's moving from one point to another. So ang flow line, it is the path of an individual particle in a moving fluid. So technically speaking, kung dyan yan, it's this path, this path, this path, and this path. This is the flow line or the path line. When we say the streamline naman, this is the curve, a curved tangent to the direction of fluid. So suppose ito yung direction ng fluid, ito yung like, sabihin natin tangent yan ito yung streamline, itong curve one. And the cross-sectional area is the edge of a flow tube where fluids flow. So in this part, so recall na natin. Since consistent naman ang kanyang radius, this part right here is the cross-sectional area. This part right here is also the cross-sectional area. And this edge is also a cross-sectional area. The cross-sectional area for usually sa tubes ay circular. May siyang radius, tapos, you know what I mean. And the area of this, again, recall ang area ng circle, it's pi times the radius quantity squared. Okay. Now, we, in calculations in physics, especially sa fluid flow, we assume for things or for assumptions when we characterize ideal fluids. Like ideal gases, ideal fluid assumptions are made para mas-simplify ang calculations. However, this is not realistic. Remember, hindi siya realistic. So, etong apat na to ay labag sa realistic, sa law of realism. The law of realism. Sa katotohanan, sa realidad. So, take it for granted only kung magkakalculate ka. However, huwag mo sabihin na tama to. This is only assumptions. So first, this is the steady flow. Pag sinabi natin steady flow, velocity of a moving fluid at any fixed point does not change with time. So it means to say that suppose meron kang tube dito, then at point A, at time equals 0, ang velocity niya is, sabihin natin 4 meters per second. Time equals 1 second. Time equals 1 hour. Ganun pa rin. 4 meters per second. Time equals 2 hour. Ganun pa rin. And so on and so forth. Consistent yan. Second is the incompressible flow. It just means that density is constant or uniform value. Di ba nga pag kino-compress natin ay isang particle, ang isang substance, nagiging mas compact yung mga particles. And because of that, nag-i-increase ang density. However, in this assumption, kasi merong time na magko-constrict ang ating what you call this, ang ating system, ang tube system, we assume that that constriction does not change the density. Yes. Okay. For the third part is the non-viscous flow. So ito yung, pag sinabi natin ng viscosity, remember, it is the resistance to flow because of the intermolecular attractions. However, in this assumption, those intermolecular forces does not cause viscosity. Ibig sabihin, no internal friction which may hinder the motion. And lastly, irrotational flow. We say here the fluid will not rotate about an axis through its own center of mass. Hindi siya nagsulat. Let's go! Sorry. Ano ba yan? And again, lastly, we have the irrotational flow. So, means the fluid will not rotate about an axis through its own center of mass. Not rotate. Ibig sabihin, because if the particle fluids rotate in a certain way, na mangyayari, minsan nag-change yung kanyang kinetic energy and nag-change yung kanyang momentum, and thus, magkakaroon ng domino effect dun sa particle. Yeah. Next. We have two types of flow. The streamline or laminar flow, this is the flow na straight lang talaga silang lahat. Kunwari straight yan, assume mo na lang. And the turbulent flow. Ito naman, yung may circle-circle. So, for example, mayroon ka like, ano dito, tail, may isang ano. And yung fluid mo like this. Pupunta siya, bilog-bilog dyan. Tataas dyan, tapos biglang bibilog-bilog, tapos yeah, parang ganyan. You know what I mean? Yeah. Yan. So yan yung turbulent flow. Whirlpool-like circles called eddies or eddy pag isa lang. Okay. Next, we have the equation of continuity. So this equation of continuity is an expression of conservation of mass during fluid flow. So sa example na ito, ang mass flow rate, delta M over delta T, is equal to ρ1 A1 V1 equals ρ2 A2 V2. So ρ1 A1 V1, this is the density times the cross-sectional area times the velocity of a fluid is consistent all throughout the tube system. Basta may single entry at single exit point. So sabihin natin dito, ang point A, ito dito ang point B. Then, the same lang ang mass flow rate in these both points. Okay, we recall that kanina nag-assume tayo that fluids are incompressible. Incompressible. Susulat ko lang. Because of that incompressibility, we imply that the density is consistent, or the density does not change. And therefore, we can cancel these densities to have the second continuity equation. This is what we call the volumetric or the volume flow rate. So the volume flow rate is equal to the cross-sectional area times the velocity. So suppose na may ganyan ka, constriction, tapos ito mas malaki. Ito yung cross-sectional area, and ng 1, ito yung cross-sectional area ng 2. We do know that the velocity here is super fast compared to the velocity here. Since we need to, they apply this kind of, what do you call this? They follow this rule. Na the volumetric flow rate for a ideal fluid is consistent in every point. Wow, click. Next. Okay, now we have the Bernoulli's equation. So Daniel Bernoulli discovered an equation that relates the pressure, flow speed, and height for the flow of an ideal incompressible fluid. So, ang nirelate dito is pressure, flow speed, and height. Okay? The work done on a unit volume of fluid by the surrounding is equal to the sum of the changes in the kinetic energy and potential energy per unit volume that occurs during the streamline flow. So kinetic energy is described by the velocity, while the potential energy can be described by both the internal energy and the height of the fluid. And thus we get this equation. So this is in terms of the pressure na. Usually, yung nakuha niya is in terms of the energy, pero dito in terms of the pressure. So we have the pressure times the pressure with respect to the velocity. So kung makikita mo to, it's like the kinetic energy expression. Ito naman the pressure with respect to the altitude. Ito naman yung gravitational potential energy expression. And pansinin mo rin na similar ang format. So, yung P1 and P2 here. 1/2 rho V1 squared and 1/2 rho V2 squared here. And rho GY1 and rho GY2 here. So, sinasabi na nito na constant ang energy. So, Bernoulli's equation is a expression of kinetic energy. Since point 1 and point 2 can be any 2 points along the flow tube, we say that this sum is constant. Okay? Okay. Now next. We have a derived, what do you call this? A derived formula. Paano naman kung ano? Sabihin natin, nag-click, ayan. Ito, tube. Then, may tubig siya. Yeah, may tubig naman siya. Tapos, eto, palabas. They experience a constant pressure of 180 m. Sa atmospheric pressure, we say that this is Torricelli's theorem. This says that the velocity of the efflux of a non-viscous liquid. So the velocity here, from an opening at a certain height below the top of the surface, this is the certain height of a liquid is the same as the velocity of an object would acquire if it is to freely fall through the same height. So we have this equation. Remember sa kinematics, the square root of 2gy, diba? Ang square root of 2gy is an expression of the velocity of a free falling body after falling some such height y. In this case naman, yung fluid, ito yung like H, ito yung Y. Bakit H yan? Let's just say that's Y. So that is Y. Tapos ang velocity palabas nito sa butas na to is V. So that's V equals square root of 2gy. Now we have what we call the Venturi effect. So this is typically observed on the Venturi meter used to measure the speed of fluid flow. Shows water flowing through a horizontal constricted pipe from a region of large cross-sectional area. Cross-sectional area in a region of smaller cross-sectional area. In this instance, the Venturi effect is observed. So, sinasabi na dito, may constriction dyan. May constriction dyan. Tapos ito yung like Venturi meter. Venturi meter. Ang sinasabi daw dito, yung yung velocity dito is lower. Pagpunta dito sa constriction, mas bibilis yung velocity niya. And pag pumalit siya dito, which the same cross-sectional area, ganun pa rin. So recall lang yung dun sa may dun sa continuous equation. And because of that, yung pressure dito sa part na to, pressure constriction, pressure dito, tapos pressure dito. So yung pressure at the constriction, tama ba? Yeah, is less than the pressure at those other parts. Why? It is because sa streamline flow, mas mabilis yung velocity. So yung pressure at the walls will be less. Okay. So, ito. As the fluid passes through a constriction, its speed increases and its pressure drops. Using the Bernoulli's equation, the theoretical pressure drop, delta P, at the constriction is given by this formula. So, delta P is equal to rho over 2 or 1/2 rho times the difference between the squares of the velocities. Kaya naman, 1/2 rho v1 squared times the square of the ratio of the cross-sectional area minus 1. So itong part na ito, nanggaling rin naman dito. Plus yung continuity equation. So i-derive nyo na lang, kaya nyo naman yan, mamaw naman kayo. Anyways. Now we have the problems. Nandito na tayo sa second part. So first, second problem, water flows through a rubber hose 2 centimeters in diameter at a velocity of 4 meters per second. For letter A, what must be the diameter of the nozzle if the water is to emerge at 20 meters per second? And letter B, what is the rate of flow in cubic meters per minute? So, meron tayong diameter and meron tayong velocity. So, pwede natin gamitin yung continuity equation. So, Q equals A1, V1 equals A2, V2. Since meron naman tayong dito, A1, so A1, ito meron tayong D1, which is 2 cm. So yung A1 natin is pi D1 squared over 4. Okay. So ang A2 naman, that's pi D2 squared over 4. So express natin yun sa ganang expression. Pi D1 squared over 4 times V1 equals pi D2 squared over 4 times V2. Magka-cancel ang pi per 4. And we're finding diameter, D2. So D2 squared is equal to D1 squared times V1 over V2. And thus, kung dito lang hanapin, then D sub 2 is equal to D sub 1 times the square root of the ratio of the velocities. So ano yung D sub 1 natin? That is 2 centimeters. 2 centimeters. Tapos, V1 natin is 4 meters per second. Tapos, ang V2 is 20 meters per second. I-plug yan sa calculator. That will be 0.894 centimeters. So that's our diameter 2 at that point where the velocity is 20 meters per second. So fina-follow niya Venturi's theorem, principle, I guess. Or Venturi effect. It's Venturi effect, okay. For letter B naman, what is the rate flow in cubic meters per minute? So recall, fluid flow, rate flow, volumetric rate flow is equal to A sub 1, B sub 1. That's equal to, ano yung A sa buwan natin? That is pi times, gawin nating cubic meters, 0.02 quantity squared divided by, this is in meters na, yeah, and divided by 4 times ano yung volume, that is 4 meters per second. So that is 1.26, I guess. Wait lang. Pi times 0.02 squared divided by 4 times 4 is 0.0126. So times 10 raised to negative 2. Oh no, negative 3 cubic meters per second. But we're finding it in terms of cubic meters per minute. So we're gonna multiply this by 60. So 60 seconds per minute. Diba? So that is 0.0754 cubic meters per minute. So that's how much, or that's how fast volume flow in that rubber hose. For number 8, a crack in the water tank has a cross-sectional area of 1 square centimeter. At which rate is water lost from the tank if the water level in the tank is 4 meters above the opening? So let's have a visualization. So may water tank ka daw dito. And binutasan, yeah, binutasan. May tubig yan syempre. Nung binutasan, nag-flow ang fluid. So may siya velocity V. Tapos ang water level daw on the tank is 4 meters above the opening. So to find the flow rate or the rate of water loss, so that's just the volumetric flow rate that is equal to the cross-sectional area times the velocity. May cross-sectional area tayo. However, how do you find the velocity here? Recall sa Torricelli's theorem that the velocity is equal to the square root of 2g delta h, or 2gh. So substitute the values. We have 1 square centimeters. So we're gonna express this in square meters para mas madalian tayo. So that is 1 times 10 raised to negative 4 square meters times square root of 2 times 9.8 meters per square seconds times ang h natin, which is 4 meters. And computing that, we have a Q value of 1 times 10 raised to negative 4 times the square root of 2 times 9.8 times 4. 8.85 times 10 raised to negative 4 cubic meters per second. So that's our answer for problem number 8. Okay, for problem number 9, water is pumped steadily out of a flooded basement at 5 meters per second through a hose of radius 1 centimeter, passing through a window 3 meters above the water line. What is the pump's power? So sabi daw dito, ano to? May flow rate dito. Tapos, may parang ganyan yung tube. May cross-section area siya na radius. So, radius is 1 centimeter. So, that's 0.01 meter. Again, we're expressing this in meters. Then, meron siyang height na, meron siyang height na 3 meters above the water line. Tapos, ang flooded basement at 5 meters per second. So, may velocity siya na 5 meters per second. So, how do you find that? So, kanina yung sinulat ko, di ba? We know that power is work by time. Okay, it's the change of work divided by the change in time. So, ang change of work, sinulat ko kanina yan, it's the change in kinetic energy plus the change in the potential energy divided by the change in time. So, ano yung change in kinetic energy? So, let's express this in terms of delta M. So, that's delta M. This is ano to? 1/2 delta M V squared plus delta M GH divided by delta T. And now let's factor out delta M. So delta M is delta M over delta T is equal times ano to? Times 1/2 V squared plus GH. And kanina, sinulat ko rin kung ano yung delta M over delta T. That is the density as a cross-sectional area times the velocity. Right? Yeah, it's right. Times 1/2 V squared plus GH. Ang cross-sectional area natin, that's radius of 1. So, ang cross-sectional area niya is, dito ko na simplify, pi times 0.01 quantity squared, that is three times 10, 3.14 times 10 raised to negative 4 square meters. So, ang expression, so this one will be equal to, let's change color. Ano density ng tubig? That's 1,000 kilogram per cubic meter. Ang area natin na 3.14 times 10 raised to negative 4 square meter. Ang velocity, ano yung velocity na binigay? That is 5 meters per second. Ito yung velocity of 5 meters per second. Times 1/2. Ano yung V? Again, that's 5 meters per second quantity squared. Plus yung G natin na 9.8 meters per second squared. And ang H na 3 meters per second. And thus, this one, ang power is equal to, simplify natin, 1,000 times 3.14 times 10 raised to negative 4 times 5 times quantity 1/2 times 5 squared plus 9.8 times 3. That is 65.8 watts. 65.8 watts. Bakit watts? Because ang unit ng power is in watts, or that's in joules per second. Okay, for number 10, this is the last problem. na medyo mahaba. The figure shows a stream of chocolate drink flowing through a hole at depth h equals 10 centimeters in a tank holding the fluid to height h equals 40 centimeters. At what distance x does the stream strikes the floor? At what depth should the second hole be made to give the same value of x? And at what depth should a hole be made to maximize x? So for letter A, we are finding the distance, x. So recall na lang, I guess. Ang velocity is the square root of 2gh. That is the square root of 2gh. At what distance x is the same sex to floor, no? So that is twice of 9.8 meters per second, square seconds, times ang h natin. Ano yung h? That's 10 centimeters or 0.1 meters. Taking the square root. So the answer is, ano yung velocity? That is 1.4 meters per second. However, that's not yet the answer. We're finding x, diba? So gagamit ka na naman ng kinematics. Ano itong height na to? Let's find this h prime. So this is the h prime. This is the height of the downward velocity. So h prime will be 40 minus, this is 40 minus 10, that is 30 centimeters. Or that's equal to 0.3 meters. Okay. So now what? So recall, since meron tayong displacement at the y, meron tayong y displacement, we're finding t, I guess. So ang delta y, or the change in y, is equal to velocity at y times t minus 1/2 gt squared. Since wala tayong initial y velocity, that's gonna be 0. And to find t, we have positive or negative. However, since wala naman negative time, we're just gonna take the positive. So that is 2 delta y. Negative 2 delta y over g. Take the square root, or in this case, 2h prime over g. So what is 2h prime? That is 2 times 0.3 meters divided by 9.8 meters per second. Taking the square root. To find the time, t equals 2 times 0.3 divided by 9.8. 0.247 meters. And ngayon, ano naman? So, yan yung t. So, we're finding x, and we know kinematics ulit that the x velocity, that's the change. So, that's gonna be x equals vx times t. We have the vx na na-compute natin kanina. That's 1.4 meters per second times yung t na 0.247. To get us an answer of 0.346. Anong unit? That is in meters. Or that's also 34.6 centimeters. So both answers are correct unless indicated kung anong unit. Okay, for letter B. At what depth should a second hole be made to give the same value of x? Now, ano yung unit? Ano to? We're finding x, diba? Again, that is vx times t. What if we didn't substitute the values? Ano yung vx natin? That is square root of 2gh Since we're in 2GH, diba? Yes, it's 2GH. And ang T natin, that is the square root of 2H prime. So, ano yung H prime natin kanina? H prime is H minus H. Big H minus H, sorry. 2 times H prime, that's big H minus H over G. If we're gonna multiply this, we will have 2 times the square root of H minus H. H minus H times H. Extend the square root dito sa H. Yes. Equals X. So if we're gonna square this, we have 4 H minus big H minus small h times H equals X squared. And thus, if we're gonna like express this in terms of H, so that's X squared equals 4 big H little h minus 4H squared. We're maximizing X, diba? So when we maximize, parang ganito siya. Ganito yung expression niya. So na yan. Hindi natin sure kung anong graph. Pero when we maximize, we are finding the part where the derivative is 0. Okay? So we're just gonna derivative this in terms of H. So we have, what do we have? Mali ko. No, mali. It's not like this yet. We're just finding the depth to give the same, ano? We're just finding the depth to give the same value of X. Sa masyadong advanced. So we have like, ano yung X natin kanina? That is 0.346 meters quantity squared equals 4 times 40 or 0.4 as our big H, H minus 4 times H squared. So for H, small h, kayo na bahala mag-solve dyan. Sa quadratic equation is equal to, we have two values. This is 0.0996 and 0.300. So this 0.0996 is actually this H. This is approximately equal to 10 centimeters. So this is not the answer. This is what we're finding. So this is in meters. This is 0.300 meters, which is approximately 30 centimeters. No, this is not approximate. This is equal mismo. So this is equal to 30 centimeters. So both answers, again, are correct unless stated otherwise. And lastly, ito na yung sinasabi ko kanina, at what depth should a hole be made to maximize X? So we have X squared equals, ano yung expression natin kanina? That is 4H, 4 big H, little h minus 4H squared. And to maximize this, we're finding the part where the dx, I mean the slope, is equal to 0. So like ano, 2x delta x dx over dh. The derivative ko to in terms of h is equal to 4h minus 8 small h. So on dx over dh, since we're maximizing this, there's no change in x for that part. So ang slope niya is like this. That is 0 for dx over dh. So this will be cancelled out. So we're finding the value of small h that will maximize this. So we have the expression, if we're gonna like simplify this, isolate this rather, that's h equals 1/2 of h, big H. So to maximize that, that will be at what? 40 centimeters divided by 2 at the altitude, at the height of 20 centimeters below the surface of the chocolate drink. So that is our answer for the letters. Again, this is for letter A. This is for letter B. And this is for letter C. So that's it for our lecture. In lecture 7, I hope that you understand this lecture. Sana naman, and good luck. Thank you for watching.